Hello everyone. Today class number 7 for electrical machine 2. Okay. So class number 7 for electrical machine 2. Okay. So today I will start the second module of your syllabus. Okay. That is the magnetic fields. Okay. So in your second module there are several types of magnetic fields are there. So basically you have to understand that how to produce the magnetic field and what are the classifications of magnetic field and every application of each type of magnetic field. Okay. So right, what is first you have to learn what is magnetic field. Okay. So first you have to learn the definition of magnetic field, right? The space around, right, the space around the poles of a magnet, the space around the poles of a magnet is called the magnetic field, up to which the force can be experienced, up to which the force can be experienced when magnetic materials when a magnetic material is placed inside the surface. So that means if we consider a magnet, suppose north pole, south pole, or for simplicity we are considering only one pole, but remember single pole, that is monopole, never exist. Okay, monopole of this magnetic field never exist. Okay, so for simplicity we are taking a north pole only. So due to this north pole, suppose this is the region of under which the force can be experienced by this north pole. Okay, that means if we placed a magnetic material, suppose if we placed a magnetic material within this region, then it can experience it will either repel or attracted. It will either repel or attracted, right? So if it is repelled, then what happened? Then the same type of charge, that is the north pole, is also present in this material. Okay, and if it is attracted, then what happened? Then actually it will be seems to like a south pole. Okay, so your magnetic field is nothing but the imaginary surface under which or up to which the force can be experienced by a pole. Okay, so this is called your magnetic field. So next you have to learn the magnetic field, magnetic flux. Next you have to learn magnetic flux. So what is magnetic flux? Magnetic flux is nothing but the imaginary path. That is the imaginary. So actually force never be seen, right? Force never be seen. But actually flux is a imaginary concept through which the force will be experienced. Suppose we are taking that this magnetic material M gets attracted towards this north pole. Okay, so if we consider this magnetic material, let's say free over here, then it will move by this way to fall in north pole. Okay, so this is the path. So this is the flux actually. So where the path of the magnetic force acting is called the magnetic flux, right? Right. The path of the magnetic force acting within the magnetic field is called magnetic flux, and it is always perpendicular, right? It is always perpendicular towards the surface of the force. Okay, it is always perpendicular towards the surface of the force. Okay, so this concept is your magnetic flux. Next, magnetic flux density. So what is magnetic flux density? Is nothing but the total amount of flux if we consider as a phi. So phi divided by A, right? So you are taking it as a B. So magnetic flux density phi by A, it will be B. So this is your magnetic flux density. Okay, so next one, magnetic field intensity. This formula, actually these concepts are very basics. Okay, so in your electromagnetic field theory subject, all of these concepts are already taught in your previous year. So next topic, magnetic field intensity. What is magnetic field intensity? Actually, magnetic field intensity is called H, denoted by H. Okay, so here we are already only taking the magnitude, so that's why you cannot put over we will not put any vector sign over any parameters. Okay, so though it is a vector parameter, H is a vector parameter, B is a vector parameter, A itself is a vector parameter, so this type of parameters are all vector, but we need not to put any vector sign, because in this subject, electrical machine, that is we are taking only magnitude, so we are taking only magnitude of it. So magnetic field intensity, the definition of it, right? Magnetic field intensity is the amount of force. Magnetic field intensity is the amount of force experienced by an unit positive charge or unit north pole. The amount of force experienced by an unit north pole when placed in a particular point inside the magnetic field, right? When it placed at a particular point inside the magnetic field. That means if we consider this magnetic material M have one unit north pole belongs to this magnetic material. Okay, then whatever the force experienced by this M is called the intensity at this point. Okay, so this is called your magnetic field intensity. Okay, so next one, magnetic flux density. What is magnetic flux density? Okay, magnetic flux density already I have been taught in previous case. So magnetic field potential. Okay, now we are moving into magnetic field potential. So what is magnetic field potential? Right, the amount of work done need to bring an unit north pole. The amount of work done need to bring an unit north pole from infinity to a particular point inside the magnetic field is called the magnetic field potential at that point of the magnetic field. So that means the work done, basically magnetic field intensity is a force and magnetic field potential is a work done. Okay, it is a work done basically, and it is a force. This concept you have to only understand, okay, for this subject. So these 1, 2, 3, 4, 5, these 5 concepts you have to learn before starting the subject matter. Okay, so let us start the subject matter of this module. That is, in this module you have to learn that, right, the magnetic fields, right, in case of electrical machine, magnetic fields are of 3 types. Magnetic fields are of 3 types. Okay, so we are categorized the magnetic field into 3 broad categories. Okay, so what are the categories? First one, right, the constant magnetic field. Constant magnetic field. Okay, and next one, right, pulsating magnetic field. Pulsating magnetic field. And third one, revolving magnetic field or rotating magnetic field, right? Rotating magnetic field. Okay, so these 3 concepts you have to understand. Okay, so what is constant magnetic field, how it is produced, and what is the application of this constant magnetic field, in which type of machine this constant magnetic field is being used, right, and how it is being used. Okay, this type of question you have to understand in this module. Okay, So actually, before start these three fields, we would like to explain. We would like to conclude one thing, that these three concepts actually common in your next modules respectively. That is, for constant magnetic field, it is basically in your machine 1. Okay, machine 1. In case of your machine 1, this constant magnetic field is already have been taught. Okay, so pulsating magnetic field is, you have to learn details in single phase induction machine. Okay, in case of your single phase induction machine, you have to learn the pulsating magnetic field. And this rotating magnetic field, in case of your 3-phase induction machine, you have to learn. In case of your 3-phase induction machine, you have to learn. And machine 1 means, so that means pulsating magnetic field, where it is produced? In case of your single phase induction motor, for a particular condition, the pulsating torque, that is the pulsating magnetic field, is produced, right? And for your rotating magnetic field, that means 3-phase induction machine, in case of your 3-phase induction machine, there is a rotating magnetic field. And constant magnetic field, it is very easy. For your DC machine, there is a constant magnetic field. And in case of your transformer, there is a constant magnetic field, right? So this type of field is constant. So first start the constant magnetic field. Do some heading, constant magnetic field. Okay, right. Constant magnetic field can produced by, write some sentence first, by Buertin. Okay, you have to write the points first. So these points are sufficient for your constant magnetic field. Okay, so write, for constant magnetic field can be produced. Constant magnetic field can be produced by any steady state current. Constant magnetic field can be produced by any steady state current flowing through any conductor, or from a uniform magnetic field developed, or from an uniform magnetic field developed by permanent magnet. Uniform magnetic field developed by permanent magnet. Okay, so by these two way, constant magnetic field is generally introduced. Okay, so first, in this first point, you have to learn this one. Okay, and in case of second point, that is how the magnetic field is produced. And in case of second point, write first, for by permanent magnetic field, that by permanent magnet. So what is the permanent magnet? Suppose you are taking a bar magnet, north pole over here and south pole over here. So how the magnetic field is produced? So all of us, it's very much clear that, and all of us, it is very much basic idea that the north pole always emits the flux, right? North pole always emits the flux, and the flux is moving by a certain path, through a certain path, and it is absorbing by the south pole, right? It is absorbing by south pole. Okay, one thing is, remember, no flux is cutting each other. Okay, so this type of flux, this is a flux, right? This is a magnetic field. So this is an uniform magnetic field. This flux phi equals to magnetic flux, and this is an uniform magnetic field for by a permanent magnet. Okay, permanent magnet always produces uniform magnetic field, which is called constant one. Okay, which is taken as a constant magnetic field. And second one, by steady state current, So what is the steady state current? Suppose you are taking the magnitude, a current having the magnitude constant, that is for all time it will be 2 ampere or it will be 3 ampere. So this type of current will produce a steady state magnetic field. That is for your DC, right? For your DC machine. Okay. So in case of your DC, suppose you are taking a conductor. Okay. So you are taking a conductor, I current is flowing through it. Okay. So due to the small differential length dl of this conductor, there will be a magnetic field developed at a certain distance r from that section of a conductor, will be can be solved by using Biot-Savart law. Okay. So by steady state current flowing through any conductor, write some sentence. Steady state current flowing through any conductor, steady state current flowing through any conductor can produce an uniform magnetic field around it. Produce an uniform magnetic field around it. Okay. So this uniform magnetic field is taken as constant magnetic field. Okay, is taken as constant magnetic field, and the theory of this concept, is called the Biot-Savart law. Is called the Biot-Savart law. Okay, so you have to learn this Biot-Savart law in your 11th or 12th standard, as well as the previous year. Okay, EMFT, electromagnetic field theory. In electromagnetic field theory, this Biot-Savart law is already have been taught. So Biot-Savart law, I think all of you are very much familiar, right? So no need to discuss the Biot-Savart law, as this Biot-Savart law is not coming to your exam purpose. Okay, so by steady state current there will be a magnetic field. So I am directly writing the equation of the magnetic field developed at that point by using the Biot-Savart principle. Okay, so that means the flux density can be written as B equals to your, what is the formula B? Your B equals to, or you can say by using this differential element dl, you can say dB first. Okay, so dB equals to mu naught into mu r by 4 pi I dl sin theta by r square. Okay, we are taking only magnitude, so no need to put a direction. Okay, so no need to put a direction. So if we consider the dl in whole for the whole conductor, so if we consider the length for whole conductor, then you have to integrate it. Okay, you have to integrate it. Okay, for a from a something A point to B point. Okay, so from A point to B point, so you can easily find the total magnetic flux density. And if we calculate the magnetic field intensity, that is dH, so dH can also be calculated, that dH equals to mu naught, or dH actually, what is the formula? B equals to mu into H, right? So that means B equals to mu into H. So H equals to what? B by mu. So these two parts are eliminated only. So 1 by 4 pi integration of I dl. So if we consider that for whole part from A to B, so from A to B it will be I dl sin theta by r square, right? So this is only magnitude. Okay, so we are taking from A to a certain point B over here. Okay, so it is very much easy, and this is for steady state current concept. So constant magnetic field can be produced by using these two concepts, by producing permanent magnet and by producing steady state current flowing through any particular conductor. Okay, so next one, write this application of the steady state current flowing through any particular permanent conductor. So after this concept, write one sentence for solenoid. What is solenoid? I think all of you are very much familiar. You are in third year. So in your third year, so solenoid is very easy thing, right? I think. Okay, so what is solenoid? First you have to learn solenoid. Okay, then you have to write the sentence. So solenoid is nothing but a ferromagnetic material over which a conductor is installed. A conductor is installed this fashion. Okay, and there will be a excitation of electrical voltage. Suppose V is supply voltage is given, and it will produce a current. So when it is producing a current, then it will be producing, suppose we are taking it's the north pole over here and south pole over here. So this one looks like similar to this bar magnet. So similar thing will be happened. So here from here it will be releasing the magnetic fields, and after traveling a certain distance it will be absorbed by south pole, corresponding south pole, right? It will be absorbed by corresponding south pole. So this concept is very much easy, I think. Okay, so this is for your solenoid. So for write some sentence for solenoid, there will be also a constant magnetic field developed. There will be a constant magnetic field also developed by a steady state current, flowing through the conductor which is installed over it. Okay, so when this current I is a constant, then the flux, whatever the emitting from this north pole and releasing, absorbing from this by the south pole, which will be uniform, that is a constant magnetic field. Okay, so this constant magnetic field has an application in your DC machine. Okay, in case of your DC machine, constant magnetic field is applicable. Okay, so now I will move into the pulsating magnetic field. Okay, so what do you mean by pulsating magnetic field? Okay, so pulsating magnetic field is what? Now put some heading pulsating magnetic field. Okay. So pulsating magnetic field is nothing but when the field is generated but there will be a pulsating in nature. Once it is positive and secondly it will be negative. Again it is positive, again it will be negative. So this is called pulsating in nature. So it no need to have the same magnitude. Okay, suppose it is a plus 2 Tesla and it will be minus 3 Tesla. So it is pulsating in nature. So whatever the magnetic flux is generated over here, exactly opposite in the next instant. So this concept is your pulsating. So pulsating magnetic field always has a undesirable thing in case of your electrical machine concept. Okay, so in case of your fast single phase induction machine, there is a chance of producing this pulsating magnetic field. So you have to eliminate this pulsating magnetic field by some external techniques. So by using the techniques you can easily improve this concept into a rotating magnetic field. Okay, so this pulsating concept will be taught in next class. So today's class up to this much. I will continue this from here, will be in next class. Okay, so today's class up to this much. Thank you.